All right, here we go. You guys that are talking, knock it off, please, and let's watch what's going on here with these problems. The population of a small town in East Georgia is 2,000. It's decreasing at a rate of zero point 0.3. Again, the first thing that you have to do to zero point 0.3 is move the decimal 2 places left. So 0.3%, as right now, the decimal's right there. Okay, so if I want to convert that to a decimal, I have to take that 0.3 and move it over here. So it becomes 0.003. So then the formula that I use in my calculator is the 2,444. So 2,444 from right there times 1 minus 0.003 to the whatever power. Okay, this particular thing is asking us to see what that 1 minus 0.003 is to make sure we can get that part. And so that's 0.997. So this is the equation that I would use. So it's letter D. Now the next thing it says use the equation from this problem to figure out the population after 8 years. So all that means is it wants us to take this thing, this little equation right here, and plug in 8. So 244 times 0.997 to the 8th power. There you go. So it's 2,385 point. Wait a minute, what are these, people?
Mm-hmm.
Yeah. So I ought to go 6. I'd round that off to the nearest whole number, 6. Again, it's approximately. Earlier up, if you watch the video, you'll see that they worked that problem. There was a problem similar to this early up there, but it said it wanted to figure out when it would double or when it would become 300 or whatever it was. Guys, if you take that same formula, 2,444 times 0.997 to the x. Guys, if you plug it into these graphing calculators and then look at the table, it's kind of cool because what the table will do for you is the table will give you every possible solution that you would ever get. That's kind of cool. There's the first year you started out at $2,444, and then the next year you would be down to here, so on and so forth. This asks for the 8th year, and look at this. That's that same 2,386 that I got. And all I did was I plugged it into my calculator and used this as a model for that situation. Same thing in the money. It says a home is worth $2,000. In 2014, it's worth $124,000. The big thing that you got to understand here is 2014 would be year what? That's not my question, guys. You're just answering a question. My question was 2014 would be year what? No, it wouldn't be 14, it wouldn't be 1. Guys, in this problem, that would be year 0. That would be year 0 because look what it says. It says a home is worth $124,000 in 2014. So if I want to do $124,000 and it increases at a rate of 10% per year, so 1.1 to the t, then that first year has to be 0. Because what's 1.1, or for that matter, what's any number to the 0 power?
1.
So 1.1 to the 0 would be 1 times 124,000 gives me 124,000. So this asks for 2018. Well, the way you do that is you take 2018, subtract 2014, and you get 4. The reason that's year 4 is because you let 2014, again, not be year 1, but be year 0, like where you start at. So 2015 would be year 1, 2016 would be year 2. That's right, there's 2, there's 3, 2018 would be year 4. Then take 4 and plug it in. Okay, That's what it says in number 11. Tell the value of the, so you can just subtract 2018 minus 2014, take your 4, plug it in. Again, if I want to show a model for every possible situation, guys, every possible situation, I can plug 124,000 times 1.1 to the x. I can plug that in there, and I can see every possible situation that would ever happen. There's my 2014, 2015, 2016, 2017, 2018, 181,548. As you just get that, you just plug that in, 124,000. 1.1 to the, what's the year again? No, I thought it was 4. Guys, it's year 4. Use your expression to tell 2000. Don't put in 2018. Put in 4. All right, now go to the next page. Guys, those first 6, if you want to see the explanation, you can go to the video. They'll be right there. Drawing that page. The ones that got the graphs on them. Okay? The ones that got the graphs on them, guys, mine, again, guys, that's what's there. I want to show you here, guys, I would rather you use this table. I would rather you use, I'm showing you right now how to use this table so that you'll be able to take that information and create your blog for it, guys. I'm showing, I'm going to step through here, and I'm going to go through every single thing that you do to use this table. Guys, the page that I got, the test that I got didn't have didn't have this table on there. It had another table on there. So what I did was I placed it in there to give to y'all because you guys asked me whether or not we could use that table, and that was a great question, and so yeah, I set it up like that. Again, it doesn't do us any good to use this table if we don't know how to use this table. And again, what I'm looking for on your blog, guys, what I'm looking is not you taking this picture and putting it there, but you taking this picture and showing you know how to use this table. So what you have is the first thing you want to do is you want to write the equation that you're going to graph right here. And it's y equals what? Something to the 1/2. Give me the second one. I don't want to do the first one.
Y equals 2 to the 1/2.
That. Okay. Again, guys, the first one, you can watch the video that'll be right there in the middle of my webpage. It'll be there later this afternoon. But guys, you put the equation right here. Okay. This equation and that right there is over here is where you write your parent graph, guys. Again, it's not that you can see this table, that you can take that table right there and paste it on your website, but you can paste it on your blog and explain where everything goes, guys. In this section right here, you put your equation that you're going to work. Okay, so that's what's written right there. I got this from the problem on the page. I got this from this section right here is the base. Guys, the base is that number that has the exponent to it. So then from the base, I take my number right there, which is A, and I place that number right here. I take this number that's right up here, guys. That number's sitting right there. That's h, and remember you take the opposite of it. So I take the opposite of that number and put right there. Okay, then the third thing you do is you take this number sitting right out here by itself. That's k, and I put that number right here. Okay, so I'm showing you how to use this table. Okay, the first thing you do is you do your parent graph. Guys, I gave these numbers, I gave these same exact numbers to you the other day. Then lo and behold, I look at a couple of the work, and y'all won't use these numbers. You won't use the information I give you right here. Okay. The first thing you do, guys, is you take 1/2, you write y equals 1/2 to the 0 power. This is 1, so that's 1. Guys, y equals 1/2 to the first power. That's 1/2. And y equals 1/2 to the second power. Guys, that's 1/2 times 1/2. Again, there's about 10 of you. I don't know why y'all do this, but you'll take 1/2 times 1/2. I tell you it's 1/4, but you write 1 right there. That's 1/2 times 1/2 is 1/4. It's not 1. That's 1 times 1 is 1, 2 times 2 is 4. So that number goes right there. Then guys, don't calculate anymore. Just take this stuff right here and flip it. Guys, 1/2 to the negative first power means you flip it to 2/1. You flip it to 4/1. Okay, now, look guys, these numbers right here, guys, those numbers right here go right there. I didn't do anything to calculate, guys. I just took those numbers right there and put them right here. I just take these numbers right here, as I take those numbers that are right there, and I put them right here. Just write them out. Guys, just put out 4, put out 2, put out 1, put out 1/2, put out 1/4. As you list them out just like that. Okay, now, how you use the rest of this table, guys, this is what I've been showing you to do right here. Whatever's right here, guys, you take -2 and add h to it and go -2 plus 0 is -2, -1 plus 0 is -1, 0 plus 0 is 0, 1 plus 0 is 1, 2 plus 0 is 2. This is now the column that's going to go there. So guys, whatever numbers are here, you write there. Okay, now do the same thing here. But guys, I'm going to do something a little different because I found out kind of the best way to use this table is to take that number right there and times all of these numbers by 2. Because that's a 2. So I'm just going to times 4 by 2. That's going to give me 8, 4, 2, 1, 1/2. Guys, I just took those numbers and multiplied. I took all of these numbers and multiplied them by whatever that A was right there is 2. Now this is the part where I lose some of you because y'all don't do it this way, guys. This is what I meant for you to do for this table. Is write this number over 5 times. Guys, because it's easy for me to see 8 plus 0. Guys, 8 plus 0 is 8. 4 plus 0 is 4. 2 plus 0 is 2. 1 plus 0 is 1. 1/2 plus 0 is 1/2. All right, now, that's my transformed y values. Those go here. Guys, just write them out. Just write out what they are. All right, now, again, guys, if you want to see what some of the ones are, it's you guys who are taking this blog and not just putting that on there, guys. Not just putting this on here, but you're explaining that you understand that you're supposed to be creative primitive, that you're supposed to come over here and graph your asymptote. So when you're working this, the first thing you do is you graph y equals 0. Again, the reason it's y equals 0 is because k is 0. As that is always that number. For those of you still struggling to see why y equals 0 is a horizontal line. Guys, look, here's a horizontal line on Desmos. I took and I plugged y equals 0 into the calculator, and it grabbed this horizontal line for me. Let me show you, look, let me show you that horizontal line is y equals a number. Look, that's it. Wherever it's at, y equals a number is always a horizontal line. Now, x equals a number is a vertical line. But we don't have to graph vertical lines in this thing because these things don't have vertical asymptotes. They only have horizontal asymptotes. So when you graph a horizontal asymptote, whatever that number is, it makes a horizontal line there. So this makes a horizontal line at 0 because this is 0. Kobe.
So the black box where it says A times Y plus K is just the whole process.
Yeah, that's just you bringing these two numbers right here together. 8 plus 0 is 8. 4 plus 0 is 4. 2 plus 0 is 2. 1 plus, and 8, this right here, A times Y plus K, is just showing me what it is that I've got them in there. Now, look, guys, graph these points. Again, this is not a linear equation. If it was a linear equation, where would you go first? You'd go to the y-intercept. Then what would you do? You move up and over the slope, whatever it is. Yes? Guys, you don't follow those directions with this stuff because this is the process that you go through to graph an exponential equation. So I come over here to my grid and I graph the point -2, 8. I put that dot, guys, I put that dot on the graph right there. That's the point -2, 8. Then I graph -1, 4. So again, -1, 4 is that red dot right there. Then I take and I do the point 0,2. So there's the point 0,2. That's the green dot. Okay. Now I got the point 1,1. So I want to graph 1,1. So here's 1,1 right there. There's 0, 0. So over 1, up 1 is the point 1,1. So that blue point is 1,1. Okay. Let's see if I can get a different color here. And the purple point is 2½ So over 2, up a half. Okay, so these, guys, eyes, these 5 points are what it looks like. Now, when you draw your graph, guys, if you draw your graph and your graph goes below the asymptote, that's wrong. As if you draw your graph and you got these 5 points right here, and you got your 5 points, and they go down here, and 1 point's up here, and then it's back down, and you draw that picture, guys, you know that's not what it is. You erase it and fix it. Guys, that's what makes you do these right. That's what makes you doing these wrong. Is that you understand that this exponential decay is going to follow, guys, it's going to follow a path. Okay, look, I missed those points. I missed them. So I may need to take my pencil here and erase that and try a little bit better to hit right on what they are. And so, guys, that's going to be good enough because I'm going to be able to see this right here. I'm going to say, oh, yeah, they got the idea of that exponential, what is it?
Okay.
Yeah, this is an exponential decay because the base is between 0 and 1. Anybody? Guys, these 5 points is the key to everything. And as I watch y'all work these 5 points, we don't seem to be understanding that this is what it is that we're trying to do right there, is graph those points. And so I created this table for you to be able to list these out. We see this, guys, for some reason or another, how I did this is what throws us for a loop, and we can't understand what's happening in this. Guys, I times that. It's easy to see those are times by 2. Then to me, it made more sense, but put this number, whatever that number is, put it the same way down through here 5 times. Because then you can read this right here before you write it right there. And so this table helps you to get those solutions. Now, again, at the end of the day, look, there's another way to make a table there. That table I meant, you could have this. At the end of the day, what I'm expecting you to do is do the exponential growth. This one's an exponential growth. This one, at the end of the day, you got to show me that you know that problem is an exponential decay. That's what it is that I'm looking for. Anybody?